Hi everybody, it's Mr. Barbier back with another video. Today's lesson is adding and subtracting fractions to finding the least common multiple, also known as the LCM. Okay, let's get right into it. So, to add or subtract unlike fractions, okay, let's remember what that means, right? Let's remember that unlike fractions are fractions in which the denominators are different. Okay, so to add or subtract unlike fractions by finding the LCM, do the following. Step 1, find the LCM, least common multiple, of the denominators. Step 2, convert each fraction into equivalent fractions with the LCM as your new denominator for each fraction, also known as the LCD, okay, least common denominator. Step 3, add or subtract the numerators and keep the new denominator the same. Step 4, simplify if needed. Okay, so you'll see in this example, right, we have unlike fractions with different denominators, right? That's what unlike fractions are, fractions with different denominators. Notice we have 2/6 and we have 3/4. Two fractions with different denominators. Now, we've already learned in the previous video, right, adding and subtracting fractions 1, that you could use the Bowtie method to solve certain problems, right, with different denominators. Now, I say certain problems because, as I said earlier in that previous video, it depends on the problem you're doing, right? So with some problems, the Bowtie method will be the most efficient way. With other problems, the least common multiple method is the better option, right? It's more time efficient. You're going to see today why that is for certain problems, okay? So we have unlike fractions, different denominators. And step 1, notice what I write here. Rewrite the problem vertically, I wrote. But you know what? These can be solved horizontally as well. So we're going to look at both methods today. We're going to look at solving problems with different denominators by writing it vertically. You see how it's written across here, left to right, but then it's rewritten vertically, right? That's one way to do it, okay? And then another way to do it is just to leave them side by side, left to right, and solve it that way. We're going to do it both ways in this video, all right? But in this example, let's look at it this way, set up this way, vertically, up and down. So after rewriting the problem vertically, right, up and down, if you choose to do so, we find the LCM of the denominators by writing out each of their multiples. Okay, by writing each of their multiples, excuse me. So you're going to see, though, ladies and gentlemen, that you see how here I have my 4 times table written out, my 6 times table written out. For this first example, I did that just to show you something very important. We're looking for the LCM of 6 and 4, right? The least common multiple. What do we mean by that? First of all, what's a multiple? These are multiples, right? The numbers that are in the times table of a specific number. So 4, 8, 12, 16, 20, 24, right? These are all in the 4 times table. These numbers here, 6, 12, 18, 24, etc., these are all in the 6 times table. These numbers are called multiples, right? So these are my multiples of 4, and these are my multiples of 6. That's what multiple means. Now, what does the C mean? Common. Well, which multiples do they have in common? Well, let's take a look. I see here, let's see. So I see 36 here and 36 here. They have that in common, right? I see 24 here and I see 24 there. They also have that number in common, okay? But what's the least? Again, least meaning the lowest. The lowest is 12, okay? So 12 is the number that I want to use because that's my least common multiple, the lowest multiple that they have in common, all right? So now you might say, Mr. Barbier, is there a faster way to get this than writing out the entire times table for each number? Absolutely. So what you do is you start with the number that's bigger. 6 is bigger than 4, all right? And what I do is I start to write the multiples of 6 and then I stop when I see a number that's also in the 4 times table. So for example, the first multiple of 6 is 6. Why? Because 6 times 1 is 6. Please don't forget that, right? Some people list multiples and they forgot to write the number itself. The number itself is a multiple of a number. So 5, for example, is a multiple of 5. Why? Because 5 times 1 is 5. So 6 is a multiple of 6 because 6 times 1 is 6. But is 6 in the 4 times table? No. So we keep going. What's 6 times 2? 12. Now stop and think. Is 12 in the 4 times table? The answer is yes, right? And then you can stop right there without having to write out all these multiples. So that's the process. So let me repeat that one more time. When you're looking for the LCM, start with the number that's bigger between the two numbers. Which number is bigger? 6 is bigger than 4, okay? So then I start my multiples. 6 times 1 is 6. 6 is not in the 4 times table, so move on. 6 times 2 is 12. Wait, hold on. 12 is in the 4 times table because 4 times 3 is 12. I found the LCM. I'm done. No need to write all these multiples out. So 12 is my LCM, least common multiple, and that number 12 will become the LCD, the least common denominator for each of these two new equivalent fractions. Now you might say, wait, Mr. Barbier, you said that earlier, right? Convert each fraction into equivalent fractions with the LCM as your new denominator for each fraction. What do you mean by equivalent fractions? In the word equivalent means equal. So ladies and gentlemen, what I want you to understand is this, right? When we put that 12 here and that 12 here, what I'm doing is I'm taking 2/6 and I'm converting it into a different form, but a form that's equal to 2/6. So if I put 12 here, right, and 12 here, look at my next step, right? Boom. 12 is now my LCM, and that becomes my LCD, least common denominator, right? Now, zoom in a little bit. Now, here's the thing that you have to make sure you do. This second step is very important, okay? Look here. For each fraction, multiply the numerator and the denominator by the same number to create equivalent fractions with the same denominator. What do I mean by that? What I mean is this, right? We want these two fractions to have the same denominator. Well, right now they do. They have a denominator of 12. But I'm converting the original fraction, 2/6, into a different a fraction that's equivalent to 2/6, but with a different denominator, right? That's the key, right? So how did I get from 6 to 12? We multiplied it by 2, right? And if you don't know that, like, say you're stuck with that, you're like, wait a minute, I don't know what number I multiplied to get that 12. Just come back up here and count. So I'm going to count 1, 2. Oh, there it is. I multiplied by 2. So 6 times 2 is 12. And please repeat this saying after me. What you do to the bottom, you must do to the top. So since we multiplied 6 by 2 to get 12, we must also multiply the numerator of the fraction 2 times 2 to get the new numerator, which is 4. Okay? So let me show you that again, right? 6 times 2 is 12. That's how we got the 12 as my LCD, my least common denominator, right? So now if I multiply the denominator by 2, I must multiply the numerator also by the same number that I multiplied the denominator by. So 2 times 2, 4. 4/12, ladies and gentlemen, is my equivalent fraction to 2/6, because all I did was multiply the numerator by 2 and the denominator by 2. Let's look at the other fraction, okay? We have here 3/4. We have a new denominator for my equivalent fraction, which is 12. What did I multiply 4 by to get 12? Again, come back up here and count if you're not sure. 1, 2, 3. That's what I multiplied by to get 12. So 4 times 3 is 12. What I do to the bottom, okay, what I do to the bottom, I must do to the top. 3 times 3 is 9. Okay, so now that we're done converting each fraction into equivalent fractions with the same denominator of 12, now I can solve the problem. Why? Because in order to add or subtract fractions, you need for the denominators to be the same. And they are finally the same. So now I can keep that denominator the same and work out the problem by adding if it's an addition problem, or subtracting if it's a subtraction problem, the numerators, okay? So since it's an addition problem, I'm going to add 4 plus 9, which gives us 13. So my answer is 13 over 12 as an improper fraction. Now, again, this answer is correct, ladies and gentlemen. There's nothing wrong with an improper fraction. This answer is correct, but you should know for your knowledge how to convert an improper fraction into a mixed number, all right? And let me remind you very quickly, it's very simple. 12 goes into 13 how many times? Okay, someone just said 1 time. That's my whole number 1 with how much left over? Okay, someone just said, Mr. Barbier, that would be 1 left over. The 1 is my numerator of the fraction. Make your fraction bar, and you keep the denominator the same. Okay, so the answer is 13 over 12, or 1 and 1/12. Okay, it's that simple, it's that simple, it's that simple. Ladies and gentlemen, that's it. That's it. The LCM method is not difficult at all. All right, so now we are going to look at some practice. Okay, now notice it says find the LCM and solve. Okay, we have 4 problems here. All right, now this is practice, so it's not, since it's not classwork you're going to do on your own. We can do this in the video. It's not a problem. We're going to do these classwork, these are practice problems right now in the video. Let's do it. Okay, let's do it. So the very first problem is 2 7 plus 8 14ths. The first thing you have to notice, ladies and gentlemen, the first thing you have to notice is this: denominators are different. You cannot solve this problem if the denominators are different in addition and subtraction, okay? In multiplication and division, it's fine. We don't need like fractions for multiplication and division, but we need them for addition and subtraction. So what method is the best method for this problem? Is it Bowtie method or is it LCM? Okay, so folks, here's the deal. I am giving you the tools, but you pick the best tool for the job, all right? I'm giving you the tools. What do I mean by that? I'm teaching you multiple ways to do problems in math. We learned the Bowtie method already, but now we're learning the LCM method. Now, some of you might say, Mr. Barbier, wait a minute, but I like Bowtie because it's easy. Can I just do Bowtie for this problem and all the problems like this? You should not do that, no. And let me tell you why. Because if we did Bowtie for this problem, right, look what would happen. We would go 7 times 8, 14 times 2, and then 7 times 14 to get the denominator. That's going to be a very big number, which you will later have to reduce. So this is a perfect example of a problem that you should not use Bowtie for. We need to use the LCM method. Okay, so let's do that. All right, so here's what we're going to do. We are going to first look at 7 and 14 and say to ourselves, wait a minute, what is the least common multiple of 7 and 14? Now, some of you see it right away, don't you? Some of you see it right away. But for those of you that don't see it, let me quickly just move to the side and show you something. All right, so we have here let me write it right here, LCM, okay, of 14 and 7. Now, I'm demonstrating this, ladies and gentlemen, but once you get really good at this, you don't need to do this part at all. This part that I'm showing you can be done in your head. As I told you earlier, we start with a bigger number. Which number is bigger, 14 or 7? I'm listening. Okay, yes, 14, obviously, right? Start with 14. And what I'm going to do is I'm going to list my 14 times table until I see a number that's already in the 7 times table. Now, some of you are saying, but Mr. Barbier, I don't know my 14 times table. Excuse me, wait a minute. You know how to add, right? Yes, you do know how to add. Okay, thank you. So don't say you don't know your 14 times table. You just keep adding 14. That's all it is. Okay, that's all it is. So start with 14 times 1, which is what? Okay, someone just said, well, obviously, Mr. Barbier, that's 14. Now, question, is 14 in the 7 times table? That you should know by heart. Yes, it is. So guess what? Stop right there. You don't need to go any further. Stop right there, right? Because 7 times 1 is what? 7. And 7 times 2 is 14. Ladies and gentlemen, there it is right there. 14 is my LCM. Done. Done. Now, some of you might have continued and gotten after 14, 28, and then said, wait a minute, Mr. Barbier, 28 is also in the 7 times table. Yeah, 28 is a common multiple, but guess what? 14 is the least common multiple. It's lower than 28. We want to use 14. We don't want to use 28. All right? All right. So come back here. I told you earlier, you can either write the problem vertically or horizontally. Let's solve this problem horizontally, left to right. All right? So watch me, right? I'm going to make a new fraction bar for each fraction. Keep the addition sign. Okay? And now my new denominator for both fractions, my LCD, least common denominator, will become 14. Okay? It'll be 14. Okay? Now, please don't forget this next very important step. Once you find the LCD, least common denominator, right? Don't just automatically keep the numerators the same. That's what students do by mistake. They just drop the 2, drop the 8. No, no, no. Okay? Remember this saying. What you do to the bottom, you must do to the top. So what did we multiply 7 by to get 14? Again, look back and count. 1, 2. We multiplied by 2. So that means if we multiplied 7 times 2 to get 14, we must multiply the numerator also by the same number. So 2 times 2 gives me what? Okay, someone just said, Mr. Barbier, that would be 4. Very good. Now look at this side. Some of you are saying, well, Mr. Barbier, but wait a minute, the 14 is already there. This is 14, that's 14, so I'm stuck. What do I do? Remember, any number times what gives you the number itself? Okay, times 1, yes. So 14 times 1 is 14. Therefore, what I do to the bottom, I do to the top. 8 times 1 is 8. Now, some of you are saying, well, Mr. Barbier, is that even necessary? Because it gives us the same number. You know what? It isn't necessary, but you should just know for the sake of proper math process that this is what's happening, right? So just know that, this is what we do. You should know the process, the full process of how to find the LCM when adding or subtracting fractions. Okay, even when multiplying by 1 doesn't change the numbers. Now we have our equivalent, we have equivalent fractions for each of these top fractions, okay? And we have the same denominator, so now we can solve the problem, all right? So let's solve it. Remember, in addition and subtraction of fractions, the whole purpose is to get the denominator to be the same. So since it's the same, we keep it the same, and we just work out the numerators. 4 plus 8 is, somebody? Okay, very good. It is 12. Now, hold on. Don't be so quick to say, yeah, I did it. Wait a minute. Look at this fraction. Can this fraction be simplified? If it can, you must simplify it. Okay, someone just said, Mr. Barbier, yes, you're right. It can be simplified. By what? Remember, simplifying means to divide the top and the bottom, the numerator and denominator, by the same number. So what's the common factor here between 12 and 14? Okay, someone just said 2. Yes, they're both even, aren't they? So what's 12 divided by 2? Someone just said 6. Good. And what's 14 divided by 2? Okay, someone just said 7. Good. So this is my final answer, 6/7. And because it's a proper fraction, there's no need to convert it into a mixed number. The top number is smaller than the bottom. Proper fraction, it stays that way. We are done. Folks, that's it. That's it for that problem. Let's look at a mixed number. okay? Mixed number time. So, some of you are thinking, wait a minute, Mr. Barbier, wait a minute. When we did multiplication and division, we had to do this process where we multiplied the denominator times the whole number and then add the answer to the numerator. And we created an improper fraction for both mixed numbers. Is that what we're going to do right now? Absolutely not. No, that is only needed for multiplication and division. There is no need to convert mixed numbers into improper fractions when adding or subtracting. So guess what, ladies and gentlemen? The process that we did earlier for number 1 is the same process for this problem. Okay, same process. Do not let the whole numbers throw you off. So let's do it. Okay, let's do it. First thing you should notice, what operation are we performing? Okay, we are subtracting. Since we're subtracting, remember, in addition and subtraction, we need to have the what? Okay, we need to have the denominators be the same, right? We need to have the same denominator, right? We need like fractions, in other words. Do we have like fractions? No, we don't, obviously, because this is a 9, this is a 12. So we need to find the what to start this problem off? We need to find the LCM of, okay, good, 9 and 12. Somebody remind me the process? Someone said, well, Mr. B, you said to start with the bigger number. That's right. Which number is bigger, 9 or 12? Okay, obviously, yes, thank you. It is 12. So, like I said, start with 12 and let's write the multiples of 12 starting with what? Okay, good. Someone said, well, Mr. Barbier, you said always start with the number itself because 12 times 1 is 12. Yes, please do that. Don't forget to start with the number itself. Is 12 in the 9 times table? No. Good. So move on. What's after 12 as far as my multiples are concerned? 12 times 2. Okay, someone said, Mr. Barbier, that would be 24. Stop right here. Is 24 in the 9 times table? Okay, someone said, nope. That's right. So we keep going. What's 12 times 3? Okay, very good. 36. Is 36 in the 9 times table? Don't tell me you're not sure. You know your 9 times table, right? You've been studying, yes? Okay, so you are sure. Tell me, is it? Okay, yes, it is. You're right. It is, isn't it? So let's list our 9 times table, our multiples for 9 until we get to 36. So 9 times 1, 9. 9 times 2, good, 18. Somebody's been studying the times tables. Thank you very much. 9 times 3, okay, good, 27. And 9 times 4, aha, 36. There is the least common multiple. And ladies and gentlemen, let me say this again, okay? This process I'm showing you here, if and when you are good with your times tables, this can be done mentally. There's no need to write it out, okay? This process should be done, honestly, mentally, once you've mastered your multiplication tables, all right? So my LCM of 12 and 9 is 36. That's going to become my LCD, my least common denominator. So let's do it, okay? So the denominators for both fractions are going to become 36. Keep the minus sign. Okay, all right, there it is. You might say, well, Mr. Barbier, should we bring the whole numbers down? Sure, bring them down. We don't really need to do anything with them right now, but bring them down, all right? Now, quick question, okay? Do we bring down the 8 and bring down the 5? Okay, someone said, no, Mr. Barbier, see, you're trying to trick me. You're right, I was trying to trick you, but you didn't get tricked. Good for you. How do we get the numerators? Somebody tell me. Okay, someone just said, I heard you. You said what we do to the bottom, we do to the top? That's right. So 9 times what is 36? Okay, very good. Somebody said, Mr. B, I forgot. Wait, look back. Count for me. 1, 2, 3, 4. Oh, okay, 9 times 4 is 36. Yes, you should have known that, but that's okay. I'll give you a free pass on that one. 9 times 4 is 36. So what you do to the bottom of the fraction, you do to the top, right? So 8 times 4, remember if I multiply this by 4, I have to multiply this by 4. is good. Someone said, Mr. B, isn't that 32? It's 32. 12 times what gave me the 36? Look back if you forgot. Count, please. 1, 2, 3. Okay, you multiplied by 3. Bring it back over here. 12 times 3 is 36. What you do to the bottom, you must do to the top. So multiply 5 also by 3. And we get what? Okay, very good. We get 15. Very good. Okay. Do we have like fractions now with the same denominator? The answer is yes, we do. Okay. Yes, we do. So now let's continue with the problem. Right. Let's finish because we got this now. So I'm going to put here equals. Okay. Now some of you are saying, Mr. Barbier, can we just do the 9 minus 4 first and get it out the way because that's easy? No, don't do that. Okay. Don't ever do that. When you're working with mixed numbers, always solve the fractions first. And there's a reason for that, okay? The reason for that is because, especially with a subtraction problem, right? The reason for that is because what if the 15 over 36 was on this side and the 32 over 36 was on this side, right? Imagine this was 9 and 15 36ths minus 4 and 32 over 36. You might say, well, Mr. Barbier, wait a minute. If the 15 was over here and the 32 was over here, you can't take 32 away from 15. Right. Which means you would have to what? Borrow from the 9, right? Cross the 9 out, make it an 8, right? Remember, there is a video that I have for renaming mixed numbers so that you can solve subtraction of mixed number problems, right? That's another word for renaming is like borrowing, right? How do you borrow when subtracting mixed numbers? Please watch that video for a refresher on that, right? I have a video for that specifically, all right? So let's continue. Work with the fractions first, do the whole numbers later. So 32 minus 15 is what? Okay, wait, I just heard someone say, Mr. Barbier, I think that, wait, hold on, don't say you think, don't say you think. When in doubt, work it out. So over here, I'm gonna work it out. Let's see, let's put it right here. So I'm gonna do 32, let me just draw a line here to separate. 32 minus 15, ladies and gentlemen, don't leave it to chance. Work it out if you're not sure. You can't take 5 from 2, right? So borrow from the 3, right? Make it a what? 2, good. And make the 2 a what? A 12. 12 minus 5 is what? Okay, good. 7. And 2 minus 1 is 1. All right, you see, ladies and gentlemen, you want to be sure. You don't want to guess. You don't want to make a careless mistake. You want to be sure. So now you're sure. 17. Okay, good. Now you're sure. So we have 17 as the numerator of the fraction, and we keep the denominator 36 exactly the same. And now we solve the whole numbers. So 9 minus 4 is what? Okay, very good. That would be 5. And there's the answer. 5 and 17 over 36. That's simple. That's simple. So ladies and gentlemen, now you're getting it. Okay? Let's look at another problem. Number 3. 1/2 minus 4 over 15. So ladies and gentlemen, guess what time it is? It is time for you to pause the video and do this problem by yourself. So do it. Go ahead, pause that video. I'm watching you. Pause that video and go for it. Okay, I'm going to assume you did this problem. You unpaused the video. You're ready to see if your answer is correct. All right, so let's not waste any time. Let's do it. So we have 1/2 minus 4 over 15. Ladies and gentlemen, we have two fractions with different denominators. We cannot solve the problem that way, so we must find the LCM of 2 and 15, or we could use, wait a minute, someone just said, wait, Mr. Barbier, wait, can we use the Bowtie method for this problem? Because, well, let me ask you a question. Why do you want to use Bowtie for this problem? Okay, someone just said, well, Mr. Barbie, well, because if I use bow tie, right, I would be multiplying 2 times 15, and my answer for that would be 30. And I would get the same answer if I did the LCM method for 2 and 15. Isn't that true? You're right. Yes. Yes. So, ladies and gentlemen, this is a problem in which bow tie is the better tool for the job. Okay? Now you might say, wait, but Mr. Barbier, you know what? I already did this using LCM. Am I wrong? No, you're not wrong. Guess what? Keep that. Keep what you did, and I want you to see that if we did LCM or if we did bow tie for this problem, the answer is going to be the same regardless. Okay? But again, I want you to see something, guys. Very simple. Some of you are still wondering, but how do I know when to use bow tie? How do I know when to use LCM? It's very simple. Let me make it very simple for you. If you multiply the two denominators by each other, and the answer you get is the same number that you would get if you used the LCM method, then you know what? Bow tie would be fine for that problem. But LCM would be fine too. Either would be fine. It's really a personal preference, all right? But in this problem specifically, bow tie is just as effective as LCM. Now, is that the case for the other two problems we did? Absolutely not. No. For the other two problems we did, if we used the bow tie method, we would be there forever reducing the fraction for number one and for number two. But for this one, it's not the case. For this one, we could use the bow tie method and it would be just as effective. So guess what I'm going to do? Let's do a throwback and do this one using bow tie. Now, whatever work you did, leave it. Don't change it because you're going to see the answer is going to be the same regardless. All right? Let's do a bow tie throwback. So how do we do it? Okay, someone just said, well, Mr. Barbie, if I remember correctly, we circle the 15 and we arrow the 1. And then we circle the 2 and arrow the 4. Okay, I call that cross multiply. Okay, and then what do? Okay, good. We multiply the denominators across. Bow tie method, right? Cross multiply, multiply across. Okay, let's do that, right? Now it's time to take the two smaller fraction bars and make one long connecting fraction bar. Yes? Okay, so follow the arrows. 15 times 1 is what? 15. That goes in the upper left. Drop the subtraction sign down the middle. 2 times 4 is what? That would be 8. So remember, always follow the arrows. 15 times 1, upper left-hand corner, that's where the answer goes. 2 times 4, upper right-hand corner, that's where the answer goes. 2 times 15 is, good, 30, that goes in the bottom. Okay, and now we just solve the top and keep the bottom the same. So my denominator is 30, and my numerator is going to be, very good, 15 minus 8 is 7, finito. Now, some of you are thinking, wow, Mr. Barbier, that was so much faster than what I just did with the LCM method. Yeah, because the problem was a bow tie method problem, okay? Now, you have to look before you leap, okay? Look at the denominators and say to yourself, if I multiply these two denominators, would I get the same number as I would if I did the LCM method? And if the answer is yes, then just use bow tie. Okay, that's it. Okay, ladies and gentlemen, we have one more to do. Number 4. Oh, and by the way, if you got this answer right using bow tie or LCM, guess what? Give yourself a pat on the back. Super proud of you. Good job. Let's look at this last problem. And again, ladies and gentlemen, again, you know what time it is. You know what time it is, okay? Pause that video. Do this problem by yourself. Go for it. I'm watching you. Pause that video. Okay, I'm going to assume you did the work. You're ready to see if your answer is right. Let's go for it. First of all, look at the denominators. Do we have the same denominator, yes or no? No, we do not, right? They're different. So we must find the LCM. Now, some of you are saying, wait a minute, but how do I know this is not a bow tie question? Well, let me ask you this. What's 10 times 4? Okay, someone just said 40. So very simple. Is there a number in the 10 times table and the 4 times table that is less than 40 that they share in common? Yeah, you knew, right? You know. It's what? It's 20, right? It's 20. Guess what? You just did that in your head. We don't need to write out the multiples then. We don't need to write out the multiples, you see? Because we're getting better at this, guys. We're getting better at this. When you're getting better, you don't need to write every single thing, right? So let's do it. We got this. So 12 is my whole number. I keep it the same. And I already know that the denominator, my LCD, right, is going to be 20 for both of the mixed numbers, right? Because you did it mentally, because you're smart, right? Good job. Now, please don't make the careless mistake. Don't just drop the 5 and drop the 3. We know better, right? We know better than to do that, right? So let me hear somebody say it. Say those magic words. Thank you. What you do to the bottom, you do to the top. So 10 times what is 20? Someone just said, Mr. B, that would be 2. So we're going to multiply 5 times 2. I hear you. 5 times 2, which is 10. Thank you. And what about the other side? Okay, someone just said, Mr. Barbier, well, 4 times 5 is 20. So what you do to the bottom, you do to the top. 3 times 5 is what? 15. Okay, look at that. Easy, simple. You see how fast you're getting with this, guys? You see how fast you're getting with this? That's because you're getting better at it. You're practicing. Okay, super proud of you. All right, let's continue. Do we have like fractions now? Yes, we do. The denominators are the same. So we keep the denominator the same. Remember, don't do the whole numbers first. Do the whole numbers last. Okay? And now work out the numerators. 10 plus 15 is what? Okay, someone just said, Mr. Barbier, that would be 25. Very good. And now do the whole numbers. 12 plus 3 is, okay, very good. That would be 15. Now, I know some of you are thinking, wait a minute, Mr. Barbier, wait a minute. Something's wrong with this answer. Well, tell me, what's wrong with it? What's wrong with it is that you have a mixed number, but the fraction part is an improper fraction. That isn't, we can't leave it like that, right? You're right, we can't leave it like that. So what are we going to do? Okay, yes, we are going to, check it out, ladies and gentlemen. We're going to ignore the 15 for now. Cover that 15, all right? Cover that 15 and just look at 25 over 20. If I told you to convert this into an improper fraction, you'd be able to do it, wouldn't you? I know you know how to do that. I know you know how to do that. Talk to me. Okay, someone just said, well, Mr. Barbier, well, doesn't 20 go into 25 one time? Yeah, it does go into, yep, that's right, one time, right? So guess what? Do me a favor. Let's just box this. Keep it away from the whole number for now. So 20 goes to 25. You said what? One time? One time. So I'm going to write it right. Let me put it right here. Let me put it, you know what? Let me leave some room. So one time with how much left over? Okay, someone just said, well, isn't that like 5, right, left over? Yeah, over what? Over 20, right? Exactly. Now you might say, well, Mr. Barbier, but what about the 15? Let's bring the 15 back, right here. But what do we do with that in this? We add it. Okay, we add it. So the whole number 15 gets added to the whole number 1, which gives us what? Okay, very good. That gives us 16. But wait a minute. Did somebody see something? You see it, don't you? You see it. The 5 over 20, do you realize that 5 over 20 can be simplified, right? We divide 5 and 20 both by what? By 5. Very good. Because that's the greatest common factor, yes? And give me the final answer. The final answer would be what? Okay, someone just said, Mr. B, that's going to be 16. Keep the whole number. And 5 into 5 once, right? And 5 into 20 4 times. The final answer is 16 and 1/4. Okay, there it is. I know what you're thinking. Wow, that was a lot of work. Well, Not really, right? Not really, because you're getting the hang of this and you got this down. Okay, I'm telling you, you got it down. So, ladies and gentlemen, you just did that. Be proud of yourself. You just did that. Okay, so now what you have to do is you have to do your classwork. Here's the classwork right here. All right, notice the classwork is 11 problems, including a word problem. All right, some of these problems you might want to use Bowtie for. Some of these problems you will definitely be using the LCM method for. Okay, but make sure that you look first before you try to solve the problem. Look before you leap. Okay, look before you leap. Some of these problems are very simple. Some of these problems don't even require any real work to do. For example, look at number 3. Look at number 3. 12 over 2 minus 9 over 3. Both of these are improper fractions. You can divide 2 into 12 and get what? Somebody say it? 6, exactly. And 3 goes into 9. How much? 3, exactly. And now just solve it. 6 minus 3 is 3. I say, wow, wait, Mr. B, we didn't do Bowtie. We didn't do, LCM. We just divided the denominator into the numerator. Yeah, sometimes the problem is that easy. Okay? Sometimes you just look at it. These were improper fractions. Look first. Look. Analyze, right? As it says here. Look at this. Use whichever method is most efficient to solve the problem. Analyze the problem first, then solve it. Hint, some problems can be solved using mental math. For example, look at number 4. 12 plus 3 3/4. A whole number plus a mixed number. Well, wait a minute. If this is just 12 with no fraction, and this is 3 3/4, that's like $3.75, right? Because 3/4 is 3/4 of a dollar. So what's $12 plus $3.75? Thank you. $15.75, or just 15 3/4. Done. That's 2 problems done for you, ladies and gentlemen, that are just mental math. No work needed for these 2. No work needed for these 2. But the rest of them, yeah, most of these, just about all of these, you're going to need to use LCM or Bowtie for. Use the method that's most efficient to solve the problem. All right? Now, you know better than to think that this is the only work you got, right? Because you also have homework on top of this, okay? So you have classwork and you have a homework sheet. And the homework sheet, remember, has 14 problems in it. Okay, it has 14 problems in it in your homework. So you do have quite a bit of work to do. So you have this to do, these 11, and then 14 homework problems, all right? So make sure you get them done, all right? Show me all of your work. And if you need any help, you know where to find me. All right, ladies and gentlemen, so that's it for today's lesson. I hope you found this video very helpful, all right? And remember, ladies and gentlemen, you are great. You are, okay? I know you are. So you just have to know that about yourself, okay? Know that you're great because you are, all right? And I will see you in the next video. Take care.